Well,
Hi, Rob.
hi, Derek. I'm just looking at the attendees list for the scores for today, and we have a very keen audience already logging on.
Really? Nice.
Yeah. So, hi guys, to everybody out there. I can't talk to you individually because there's so many of you, but just for you that don't know Derek Calloway is someone I've known since I've been working in the industry. Is managing director of Dewhurst's Airfield lighting, or is Dewhurst? What's the correct name? Dewhurst
Airfield Services Limited.
And your moment of fame. What do you tell the audience? What Dewhurst Airfield Services do?
Oh, wow, we do everything. We're primarily based in the UK, doing airfield lighting installations. Originally, I was with GC, Alstom, Sedgwick, and then I joined Edward Dewhurst 21 years ago to do the airfield lighting installations, and we created our own company out of Edward Dewhurst 2 years ago. Right. But very successful in the UK.
For those of you joining, we're early. We're now 10 minutes before the start. I congratulate you. We welcome you for joining us, Keith. I'm just saying we have quite a number of people who have joined us early today. I don't know if my clock is wrong, but I make it 10 minutes to 2. But I welcome everybody nonetheless. Derek has just introduced himself, and now it's always good to put a surprise on someone. But I learned something very interesting today, Derek, and that is that you, in fact, used to work with Keith in the past.
I did a long time ago.
Yes. So tell us about. So that's why you know so much, is it, Derek?
Well, yeah, I used to have to just get the cups of tea and coffee for him. You know, he was awful to work with.
Oh, the same as I do now, then.
Well, thank you very much, Mr. Calloway. I recall the first installation job I think you went out on. I think it was Glasgow, wasn't it? I think something like that. It was. We had a project, and I wasn't directly involved at all in it. And I think you went out. I think it was in Scotland. It was in Scotland somewhere. I remember you going up north, and it was your first one of your first.
Aberdeen approach lighting.
Aberdeen, yeah.
Yes.
Yeah. It's gosh, it's a long time ago. You've done some miles since then, Derek.
It doesn't show though, does it?
No, of course not.
And when would that Aberdeen approach job have been? What year roughly?
That was 1990.
Yeah, 89, 90, something like that.
Yeah. And it was the Jackwith approach masts, basically a kit of Meccano, all those clamps and thousands of nuts and bolts. Yeah, the old tripod arrangement. A lot easier now with Excel and pole light.
Yeah.
The reason.
A lot of water under the bridge since then, you know, and we've seen a lot of changes in many ways, you know, with technology advances, etc. And of course, Derek has been more actively involved in the project side and the installation. And one of the issues that we'll discuss a little later is the specifications associated with projects.
Yeah.
Very interesting. You know, I might as well say it now. I brought that subject up. You know, in all the years, I don't think I have ever seen project documentation where you've got the commercial side, which defines standards. Then you have the technical specification, which declares the range of the types of equipment that is needed, etc. Then a set of drawings, and the three don't match. and so Derek is a specialist in being able to decipher the actual requirements, Derek.
Yes. You've got to be careful when you're putting a tender together, because I mean, the better the specification is, the better responses you'll get from tenderers, and the better you'll be able to compare them. But when you've got a cut and paste specification and a drawing that doesn't reflect the job, everybody puts their own interpretation on it, and then you'll get varying quotations, which could be 2 times, 3 times the cheapest one.
Exactly.
Yeah, it's quite, even when performing photometric tests, it is regular that when we commission an airfield's lighting system, the what's actually there never matches exactly the as-built drawings. And I guess I still find that surprising, especially with today's technology. But it's regularly, well, it's always the case.
Yeah.
I think one of the things, though, Robert, is what we have to appreciate is that in our AGL world, we are mostly dealing through main contractors who are principally civil engineers. And so they have a lot of in-depth expertise and do a really good job on all the civil engineering side of airfield projects. And then we, as the electrical side, the AGL, and if it's in pavement or inset lights, we come in and cut a hole in it, you know. and to have a full understanding of the needs of AGL, and it's not our fault, we need to do it, you know, but for civil engineers to have that full understanding of the needs of the AGL side, that's where you know, some of the issues and the conflicts can come in. It really is. Because one of the things that we have to do when we put in pavement lights, inset lights, into a pavement that meets the ACN, PCN factor, for example, then we've got to return the integrity of the pavement as near as practicably back to its original structural strength. And that's not easy, right? Because whatever you do to any structure, if you drill something into it, you're going to weaken it in some form or another. And it creates, that's really a conflict area, really.
Yes.
You know?
So Keith, it's 5 minutes to the official start time. We have almost 30 people on the call already. So I'd like to thank you for everybody for their enthusiasm in joining us so early. We won't start the official presentation yet, because there are still 5 minutes and we have almost 150 people registered for today's call. So we always get a rush just exactly on time. So it would not be fair to start early. But what I would like to ask is that, as you know, today we have planned a question and answer session. So can you please consider now and during the course of the presentation any questions that you would like to answer the panel? So you can see in front of you now. Paul Smith hasn't been introduced to you yet. We'll introduce ourselves formally later on. But Paul, if you'd like to make a brief introduction.
Hi, yes, I'm Paul Smith, work with TaylorMade Systems, and quite a few of you will probably already know me as I do a lot of commissioning and installation of our products. I travel worldwide to provide the services of training you guys on how to use the equipment and to set up your photometric trailers and cleaning equipment for use with your airfield lighting.
Thank you, Paul. And I hope most of you I know have already been on these calls, but just in case there's any new faces there, my name is Robert Shapton. I'm Managing Director of TMS Training Solutions, as well as TMS MARMS. And I'd like to welcome you and thank you all for taking your very valuable time to join us all today. But I'd also like to thank my wonderful panel of experts here, because they really do have an extraordinary amount of knowledge and understanding, specifically relating to installation and maintenance of visual aids. And this is a wonderful opportunity for you to ask any questions you might have. Those answers you'll get live in the Q&A session at the end of today's presentation. And also we'll be posting the answers on our TMS Training Solutions website, as we will also a copy of the a video of this recording of this webinar, so you can reflect, or if there are any points you want to specifically check up on, you can re-look at the video, the recording afterwards. So we're now 3 minutes to go, 3 minutes to kick off. Once again, we have many more participants than any Premier Football League match currently being played. So very, very proud for us all. I shouldn't joke, really. It's very sad, of course, the cause of this problem. But anyway, let's be positive and use the opportunity to spend time thinking about our projects, our installation work, any new works we might need to do, and any maintenance, because continuous maintenance, planned preventative maintenance is, of course, essential. Because even though commercial passenger traffic is regular passenger traffic is virtually at a standstill. Although last night I was at an airport in Scotland where they're starting operations again, limited operations, but they're starting nevertheless. Cargo traffic has continued throughout this period, and whether it's one plane or 1,000 planes, they still need the runway still needs to be operated safely in all respects, and particularly in low visibility conditions where the performance of your visual aids are crucial. So we're now one minute from action. As I said, if you can put any questions on the questions, there's a questions tab on your computer where you can ask those questions, and we'll bring those up at the end of the meeting. We will also be introducing the future webinars, and Tony Smith, who is doing a PAPI webinar 2 weeks from now, specifically asked me this morning if you'd like to think of questions for him, because it is a very complex area, and he'd like as much time. Tony Smith is now a very young 80-year-old, and he's celebrating his wedding anniversary today. So I'd like to congratulate Tony and Diana on their wedding anniversary. I think it's 58 years today. So congratulations from all of us, Tony. And he would like as much time as possible to prepare for some what could be quite detailed questions. I know one of the particular areas he's going to be focusing on is ILS and PAPI alignment, which is a particularly challenging issue. And I think there may even be some issues with the regulations that need to be addressed that Tony is currently working on. So it is now 2 o'clock. Keith, you now have control of the screen if you want to load your presentation. I'd like to introduce you all today. Today's topic is installation and maintenance of visual aids. We will start with a presentation for about half an hour made by Keith, and that will be followed by a live panel question and answer session where our experts, installer, Managing Director of Dewhurst Airfield Solutions Limited, Derek Calloway, will be talking all about installation. We have Keith, of course, who knows everything, and Paul Smith, who'd be known to many of you as a person who does commissioning and testing of your runway lights. So without any further ado, I'd like you to hand you over to Keith now, and if Derek, Paul, and myself, we will just mute mute and stop our videos. Then you just see Keith and his presentation. Thank you very much, Keith.
Okay, can you hear me okay? And see my presentation?
We can, Keith.
Thank you. I'd say good afternoon for those in this part of Europe. Good morning for those that are across the pond. and in the Americas, and good afternoon and good evening for those who are in the Middle East and in the Far East. So hi everyone. Interestingly, thank you, Robert. Interestingly, you know, we are coming out of COVID-19, and all our countries are now starting to actually change the regulations associated with social distances and etc. However, you know, without further ado, what I want to be able to discuss this week initially, and then with our panelists afterwards, is both airfield ground lighting, installation, and maintenance. So let's see where we've come from. We've done 4 webinars up to date, and basically we've covered in our 4 webinars 3 steps of in this working airside and working airside on AGL safely. And so there you will see on the screen here. But the key issue for us is to discuss how technology is changing also, and how AGL is changing, how we must change as the designers, the suppliers, the installation contractors, the maintenance personnel, and the regulators, etc. We must understand that AGL has changed. And we've, as you'll see at the bottom of this slide, then AGL, which we've introduced in individual light control and monitoring, ILCMS, that's integral to be able to have surface movement guidance and be able to control those lights. So we now moved into advanced surface movement guidance, and that information needs to be on tap, immediate, reliable, and especially if we're going to be able as an input into collaborative decision making. So we have become part of the communication, navigation, and the surveillance packages of an airport operation, CNS. So just to remind you, in our TMS Learning and Development Centre, we concentrate on AGL and concentrate on ground traffic management. 3 key issues: safety, compliance, and competence. Safety, naturally, safety of aircraft, safety of people. Compliance, operational compliance, and the competence, that is our ability to be able to have the knowledge, the skill, etc., to be able to keep our lights burning, because that's what we're talking about. And ultimately enabling operational excellence and have that engineering competency. Last week we posed a couple of questions, and just for you to ask yourselves, I'll just bring them up again. And the questions are: do you have the knowledge, the skill to understand and answer these particular 3 questions? And basically what will happen in this diagram here, there is just a simple, very simple AGL circuit with 10 lights in, and fed from a CCR. And there are some points in there, A to F. And so just ask some questions, very simple questions. What will happen to each light in the AGL circuit above if there's a direct short to earth between A and F? A and F. So if that's a short to earth there and a short to earth there, what happens to all those lights? Well, current will leave the CCR, go to earth, come back in there and go back to CCR. All those lights will go out. As simple as that. B, what will happen to each light if there's a high resistance at C and a direct short to earth at D? High resistance. That means that if that earth path between C and D, there is resistance there, which means that when current gets to this point here, it is shared itself between this path and that path. So in this circuit, on this particular occasion, lights 1 to 4 will remain on. 5, 6, 7, and 8 will be dim, and 9 and 10 will be on. And so what happens in C? What will happen to each light in the circuit above when there is an earth at B and an open circuit at E? So we've got E and we've got B, an open circuit at E. Open circuit, that means no current can flow anywhere. So the CCR will trip out. So all those lights, 1 to 10, will be off. Simple as that. And then I asked you a question, the next question we asked, which was about installation resistance values. Now, installation resistance values, well, if installation resistance values, a category 3 runway center line, well, I would say to you, just draw the circuit. And runway length, 4,500 meters. Substation, 500 meters away, with transformer pits, interleaved. Well, we're going to discuss this afterwards. So if I'm not going to go through it in this presentation, but what I would say to you is think about that, because this is pretty fundamental in our knowledge. So if you want to discuss this with me, please contact me later. So let's go onward to this presentation in webinar 5. AGL has changed. We need to have the knowledge, the skill and the attitude for different technologies from yesteryear. And remember, if we're going to have operational compliance, if we're going to demonstrate that we are competent, then you cannot manage what you cannot measure. So if you've got a light fixture and you've got a lighting systems, you need to know what that photometric output is. So the question is, also, you know, a lot of people say, oh, but training, you know, training gives people value. And when they get value, they leave. Well, the question I always ask is, what if we train people and they leave? But a good answer is, what if we do not train them and they stay? Think about it. So if you think training is expensive, try an accident out in the field. Let's have a look at the concept of the airfield ground lighting and ground traffic management life cycle. The global concept. We start really at this stage, the consultation stage and the design stage. Now, there are a lot of major consultant companies around the globe that offer their services to airports and define the specifications. We're going to have a look at specifications a little bit later in our panel and maybe discuss it. But then it comes to installation. If you do not do a good installation, then how on earth can we maintain? So installation and maintenance directly affects operations. So from our perspective, 2 key issues in the life cycle of airfield ground lighting. Now, we do know that AGL is split into 3 simple blocks, the traditional AGL in 3 simple blocks. We have the power side, and the actual power for AGL is from the constant current regulator in a traditional system. We have the distribution side out into the field and the light fixtures out in the field, and they're controlled by the air traffic control up in the control tower by one method or another. So they're the 3 simple blocks. And from a practical viewpoint, this is what it looks like. What we're going to do there is really just concentrate on this side. We will talk about CCRs and control systems at a later date. But here we're going to talk about this area. Bear in mind a traditional system, 5 kV 6.6 amp system, which is used pretty exclusively around the world, then the voltages that are on the output terminals of this machine here, it could be up to, for a 30 kVA CCR, 4,545 volts across there. That is, all this equipment out here is rated for 5,000 volt operating. 5,000 volts kills and 6.6 amps kills. We normally say though, voltage burns, current kills. Think about it. And so here, look, I've put primary circuit, secondary circuit, and other components. And I've crossed out some of the components in this on this slide because we're not going to be dealing with them in this particular webinar. So we will look at primary cable and connectors with the isolating transformers. So we're going to concentrate really on that side. So let's move on. Installation itself. What does an AGL contractor want? Well, they want to do a safe installation, but they need access to do that and time to be able to work on the infrastructure. But they are contractors. They need to make a profit. And the way they make a profit is to do a good job and have no warranty issues afterwards. Excuse me, I just jumped over too quickly. What does the customer, airport customer, want? Well, basically exactly the same things, eh? But they don't want any hassle. They don't want any extensions to time. They don't want extra cost. And they certainly want to have an efficient maintenance capability afterwards. So these are the this kind of cycle associated with installation is really, really important. And that's really the message what we want to get across today is, but what equipment are we talking about? We're talking about elevated lights, those that stick above the ground. Well, in elevated lights, then there are basically three factors. Those that sit on the ground, those that stick above the ground up to 1.8 meters, and those that are above 1.8 meters. And they're the criteria. And the criteria associated with that is known as frangibility. That means that if an aircraft did hit our light fixtures and the mounting equipment, then the light fixture and the mounting equipment breaks and the aircraft stays whole, basically. And the Aerodrome Design Manual, ICAO's Aerodrome Design Manual Part 6, defines that frangibility element. So elevated lights are those that stick above the ground. The other is in-pavement lights or inset lights, those that we put into the pavement. But there are two types of pavement. There's rigid pavement and flexible pavement. Rigid is concrete, flexible, asphalt, normally asphalt. And there are two different requirements associated with the pavement itself. But to actually install the light fixture into the pavement, we have to put them into a base unit or a can. There are different names for it around the world. But there are two principal workings. There is the deep base concept and the shallow base concept. The deep base concept is principally used by the Americans, principally the FAA. There we find them around the world where there's some American influence or American contractors or consultant working. They will have deep base. Now you'll see here, look, a deep base. Now here's a picture of a deep base, but that's a solid deep base. Now a solid deep base is where you would install as a complete unit, maybe into into concrete, for example. But if you were using asphalt, which we install in layers, then you would have to have a sectional deep base and build it up as the layers of asphalt build up. whereby in a shallow base, then the pavement is complete. And then after the pavement is complete, then we core a hole. And this is where I mentioned earlier, there's issues associated with potential with that, because the civil engineers do a brilliant job to make us a good, strong pavement, structural strong pavement, which meets what is called the ACN PCN factor, aircraft classification number, pavement classification number, and then we can cut a hole in it, but not just cut a hole to put this unfamiliar product in there, because it's dissimilar. It's not made of asphalt, it's aluminium alloy. So we've got dissimilar materials there. So what we have to do is to glue this in to the hole that we core with some kind of resin of suitably approved resin. But we've also got to get the electrical cable out to the light fixture. So this is quite a challenging thing to do, and there are different methods of how we get the electrical cabling to the light fixture, especially if it's a touchdown zone or a runway centerline light, which is out into the pavement, or a taxiway centerline light. So two types of lights: elevated lights, inset lights, bring different demands for installation. Here's another picture where if we're going to install light fixtures into rigid pavement is installed not in layers, but in slabs, in blocks. And between the blocks are expansion joints. So I brought this little picture up because we have to consider the electrical cable. Let's say if this is a touchdown zone or a taxiway center line or a runway center line light, etc., and our transformer is off to the side of the pavement, we've got to get the secondary cabling, the secondary circuit, out to the light fixture across an expansion joint. Well, it's no good just putting the cable straight across, because as the surface moves with temperature changes, then it would break the cable. So there's different demands, and this picture is taken, and here we acknowledge Possil, the Netherlands. Possil, they produce not just the epoxy type of resin for the various functions. Here, look, is a whole range of epoxy-based material that Possil produce. But also they have specialist tools, and they also have an installation team. So they're pretty all round. So we acknowledge, thank you very much to Possil for allowing us to use this information. Again, I will stay on this same subject, because the material, epoxy-based material for gluing the base unit into pavement, etc., and the specialist tools of their own design for installation. But then it comes to the cable itself. Now, the cable goes from the CCR, and it's a series loop, so it's a single core cable for the primary circuit. Goes from the CCR in a substation, volt, B center, call it what you like, and goes all the way around the circuit and back. Hundreds and hundreds of kilometers of this, and there's various types. And there's type A, B, C, and fly-C. Probably the most widely used cable that is used is type C, which is XLPE insulated cross-linked polyethylene. Cross-linked polyethylene. And it's a single core. It could be solid, but it's mostly stranded of the copper current carrying conductor. But there are two types. There's screen cable. That means it has a screen of some material. And there's unscreened cable. In the ICAO world, we tend to use screen cable. In the FAA world, unscreened cable. and so there are differences. Certainly there's going to be differences in the installation, because when we use unscreened cable, it's very important that we have an earthing network called a counterpoise earthing network for lightning protection, especially in areas where there is the potential of electrical storms. So unscreened cable, we have additional earthing cables installed, whereby in the IKO world with screen cable, we may or may not have the additional earthing cable, the counterpoise earthing cable for lightning protection. Installing cabling, hundreds and hundreds. Well, we can either put cable directly in the ground, or we can put them in ducts in the ground. But whatever we've got to do, we've got to connect that primary cabling to isolating transformers. And those isolating transformers are going to be housed somewhere. So here's a couple of pictures of typical concrete, locally manufactured transformer pits. Transformer pits, major issues with transformer pits of different sizes, different types, different models, but whatever it is, they've got to house the isolating transformers and the associated connections, because transformers come from the manufacturer with molded plugs and sockets on. We install the cabling in the field, and we put the appropriate connectors, primary connectors, onto the cabling to be able to connect together. And that is a major installation issue, basically, because if I've got a runway center line and I need to get the cable, the secondary cable from a transformer pit out to the light fixture, I've either got to decide, do I put it in ducts, onto the pavement, or do I cut a sword cut across the pavement? So whatever the design is, then we have to decide what we're going to do. When it comes to the primary cable, then when the primary cable, how are we going to put it? Directly bury it or put it in ducts? If we've got a transformer pit, as shown here, and we have ducts, and I'll just move on to some additional pictures associated with laying cable. But one of the key issues that we have to consider is that these transformer pits, if you've got what is called a pit and duct system, there's some ducts and that's a pit, then this becomes part of the airfield drainage system by default. Now, ideally, we want those to be nice and clean and dry. The reality in most of the world, that's not the case. So that's a knock-on effect to maintenance, which we have, and the insulation resistance failures, which we can discuss a little later. And then onwards, a few more pictures just to show this is a project from in North Africa, which I was involved with. So some nice pictures there. But this is the reality of what installation contractors have to consider. And I say it's hundreds and hundreds and hundreds of kilometers of cable, primary cable, are installed in a traditional AGL system. The other aspect is what we need to consider is that cable separation, but also if we've got communication cable, we cannot have communication cable adjacent to power cable. So that's a fundamental consideration. Also, when we're installing cable, there is the criteria associated with bending allowance and also with tension. As can you imagine, if you've got a transformer pit alongside a runway, as shown here, and I got another transformer pit 60 meters down there, then the cable's got to go down there in a duct, along, and be pulled back up out of the next transformer pit. So the pulling tension is really important. So generically speaking, whatever the cross-sectional area of the cable is, of the current carrying conductor, so normally you use 6 millimeter square. So 6 millimeter square, that is 50 newtons per millimeter square. So for an AGL primary cable, that's 300 newtons we cannot exceed. And the bending allowance depends on its screen cable or unscreened cable. So screen cable is 12 times the outer diameter, unscreened cables 5 times. So that's the bending allowance. And we also need to protect cable across sharp edges of transformer pits. And here's one method of doing it. That is taking the PVC piping, very good way of doing it, cut it in half and lay it over so that the cable runs over PVC. A pretty good way of doing it. So cable types, screened or unscreened, and the size of connectors has got to be chosen accordingly. And we have also in connectors need to have, for the documentation, and I think something which Derek from Dewhurst we may discuss, have time to discuss hopefully, is that this is a risk, eh? So we need also to do risk assessments. We also need to have a method statement, which is clearly defined how we're going to install equipment. So method statements, and this is an example, and I acknowledge Perfect Airport Solutions of Singapore. This is a project that we did together in Kabul, in Afghanistan, and this is with the Japanese main contractors, and this is the method statement associated with putting the connectors on, the primary connectors, and even various pictures of how to do it, instructions step by step, including all the tools that are needed. Method statements, pretty extensive documents are needed for or provided by the installation contractor that is approved in advance of work starting. So connectors, various types of connectors. The connectors is an FAA, an American Federal Aviation Administration standard that's been adopted worldwide. Type 1, which are primary, type 2 for secondary cabling, and there's various classes. That is, some are molded, which is done in the factory. For example, you get a transformer, isolating transformer, then the connectors, male and female, will be molded on in the factory, whereby to connect to the cabling in the field, we've got field assembled kit. So there's the different types, and there's types for screen cable, unscreened cable. There is a typical, well, basically, when we're putting a cable in and putting a connector onto a cable, this is using the male, showing the male connector rather than the female connector. And it's an interference fit because we want it to be watertight. So there's some criteria associated with how we make it watertight, and the instructions will come from the manufacturer of the connectors. And if we do not get it watertight, we get this wrong, water will leak inside here, and it will short to earth, and then it will corrode, and it will blow open into an open circuit. And so we've got failure in both counts. Going onwards to the contractors themselves. Now here is, and thank you to Dewhurst Airfield Services for this slide, because there's quite a lot of issues, as you can imagine, associated. I've already mentioned was unclear specifications or unclear definitions associated with what is actually needed. There's always grey areas, and we need to have site visits to clarify exactly what we're talking about. The main contractors themselves, they've got their own program, they've got their own priorities, and as I mentioned earlier, they're normally civil engineers. So we're coming along and deteriorating what they've already done if we're going to cut a hole in the asphalt. Communication is is really can be an issue, especially if we're working with different nationalities, with different languages, is to have an understanding and an appreciation. I mean, the international language, for me, I'm lucky because it's English, and English is my mother tongue. So I'm pretty lucky in that respect. But communication can be difficult. Access airside is a nightmare. Everybody knows who work in an airport. You spend your life going through security, getting passes, airfield access passes, permits, etc. It can be a nightmare. But also, what we also got to understand is that we're working with a system that has voltages in excess of 1,000 volts. So we've also got to have authorized persons associated with our project. So an installation contractor needs to have that in his portfolio also. And supplier deliveries. How often have we had, oh yes, you can have it in 3 months. If you give us the order, you can have it in 3 months. Of course, in 3 months, then they say, well, a bit of a delay, it'd be 4 months or maybe even 5. And then suddenly it's 8 months before you get the kit. Now that's the knock-on effect to project timescale. It's all about, and ultimately it's money, you know, and then you're into liquidated damage period. So all those elements have to be considered. And resources, you know, the people, the guys themselves who are working out there, are they competent? Are you train them? They have value, they go to work for the opposition. And working hours, traveling hours, there's legal requirements associated with, you know, the hours of work, and so that work-life balance associated with occupational health, etc. So there's a whole range associated with resources. And this is just a sample of what we have to consider. Onwards, practical issues like weather. Well, if you get an electrical storm, you're pulled offside. You can't work out there in an electrical storm. You become a target for lightning, you know, for example. What about operational delays? So you cannot get access onto what is done, what you need to do. So, for example, in a very generic way, if I've got a runway from midnight until 6, what's if there's delayed flights? Then suddenly you don't get them until 1 o'clock. Or there's some emergency, so they need the runway. All this is a knock-on effect. So generally speaking, very generally speaking, and I don't want anyone to shout back at me at this, but if I'm planning a project, then I tend to think when I've got a 6-hour period, for example, 3 hours of it is unproductive time, 3 hours of it is productive. So there's your ratio. If you can get more than 50% productive time, then, you know, you're on a winner. It's as simple as that. You know, so you can mitigate some of the things, which can, but it does affect your program. I mean, equipment breaks down. So, you know, these are the kind of things. And so once again, I thank you very much for Dewhurst for you know, providing me with this slide and this kind of information. Onwards, you know, to looking at installation and maintenance. 4 key issues: installation and the material associated with the installation itself, all the tools and test equipment, the program itself, and the personnel. So they're the 4 key issues that we tend to always put our project control under these 4 areas. So let's move on to maintenance itself. I'll show this picture again, but with some different elements on the side, different aspects on the side, because when we're looking at these aspects on the side, maintenance team, when we want the equipment to be suitably installed and commissioned, you know, and of course we need access to do maintenance, and that is the time to do it. And we don't want warranty issues, knock-on effect from the installation contractor. Airports want the same as maintenance, just the same. They just want a compliant system. They don't want, that's it. They just want the system to be operational, compliant upon demand. And that's the key issues associated with maintenance. So very similar, installation and maintenance go hand in glove together. So the objectives is to aid in the safe operation of the aircraft. Serviceability is dependent upon the effectiveness of the maintenance people and the maintenance work, and we need to have the suitable records, etc. So we need to have a maintenance management structure to be able to do that. And a typical structure is to the boss, the engineer, the technician, etc. But because we're working with voltages in excess of 1,000 volt on a traditional system, then we are talking about having authorized persons. So these two things go together. So just let's summarize. We need to have a lot of reference documents, manuals, etc. We need to have the organization and the philosophy and the mentality to do maintenance and at whatever schedule is required. We need to keep the records and associated with our both preventive and breakdown maintenance. And those records have to be retained according to your national standards. For whether it's 5 years or 10 years, we need to keep records. And like everything else, if you don't have spare parts, it's going to be a little difficult to keep that AGL compliant. So spare parts provisioning is pretty fundamental. So let's have just summarize here what an airport's looking for maintenance. They want to maximize the operations and do it safely. And also from an airport, if you're doing maintenance correctly, we're going to optimize, you're going to extend the useful life of equipment. That means that your budgets are not going to be affected. There's no point in saying, oh, I've got a new piece of equipment, we haven't maintained it, I've got to change it again in 12 months' time or 2 years' time. So that kind of element. But from an operational viewpoint, then if we do maintenance, preventive maintenance, then we're going to reduce breakdowns. Reducing breakdowns then means that we do not affect operations. So this is a nice little diagram to explain the main objectives. Now this is available to you these online from our website after the webinar. Failure. Basically, there will be failure. There'll be breakdowns. It'll happen. You know, your car breaks down. Even if you maintain it, it'll break down. A tire will burst, you know. So it's the same in the field, you know, something will happen. There'll be sudden failure. But if you've got good maintenance, then you reduce the gradual failure. Because remember, the systems are in the ground for many, many years, so they will gradually deteriorate. So there's the element of we need to have that understanding that we do have to do an analysis of how long it's going to be before we have to replace our AGL. So in terms of maintenance, principally two types, corrective maintenance and preventive maintenance. But in today's technology, we can now add predictive maintenance, because if we've got suitable records and we can look at records, we can now predict the life cycle and the time when we can do maintenance. I think ICAO in the aerodrome design manual, part 4 called it differential maintenance. I tend to call it targeted maintenance. But but we can predict. So the life cycle I've mentioned, compliance is the respectful of standards. We've still got our standards to consider. We also need to take the people and ensure that they retain their competence. No good having somebody and say, and I've listened to AGL engineers around airports and say, yeah, I've been here 20 years. I know everything about my airport. Nobody knows everything about their airport. We do need to have continuous updates because equipment change, technology changes. And I know I already mentioned about the preventive concept of doing scheduled inspections, etc., and spare parts and tools as well. Don't forget tools. Tools need to be tested once a year. So onwards then to the different types of serviceability inspections, etc. And depending on the operational category of your airfield, your airport, Cat 1, Cat 2 or Cat 3 ABC, then there are some serviceability levels that we have to take to consideration. And this is this part of the certification process. So if you wanted further discussions about your performance criteria from an AGL for the different categories, please contact us separately. But in principle, when we're looking at AGL, when we look at an individual light output, then ICAO defined that when the light output falls to below its need, that is below its standard, in accordance with the ICAO Annex 14, then when it falls to 50%, it's deemed to be unserviceable. But note, then if it falls to 70%, we should consider doing maintenance. So there's a criteria. 50% is mandatory. 70% is recommended. And you might wish to start at 80%, or you may wait a little later and do it at 60%. I don't advise that. It's better to do it maintenance, rectification maintenance earlier than later, before it becomes non-compliant. And how do you check for compliance? Well, photometric test is a pretty fundamental way of doing it. And if you want to use a mobile photometric tool, you can do a runway edge lighting system on a runway of around 3 to 3.5 kilometers long, then in 5 minutes, less than 5 minutes. And in that time, the results in the technology of the mobile testing capability of today, then the results are immediate. It's in real time. So you can actually tell if you do a photometric check, you can actually do the rectification pretty much immediately if you have that time and to do so. So there's a real advantage of using a reliable and a repeatable photometric tool. So let's come into an effective asset management system. Then the effective then there are tools available today, and one of the and if you wish to discuss a suitable system for your AGL asset management, doing things like automated recording of checking the bolt tightness of inset lights in the field, in the pavement, or the photometric results, or cleaning, just cleaning regime, because lights get dirty. I mean, rubber burns off aircraft tires onto lights, and if you put a film in front of a light, if I've got a torch, shine a torch and put my hand in front, you can't see the light on the other side. It's just the same for a light fixture in the field. You put rubber in front, you can't see the light on the other side, or a reduced light. So if you've got an electronic method of recording those results and being able to bring it up in real time, and then we can help you. And it's as simple as that. Talk to us later. So what have we really discussed here? And this is really comes, we need to have knowledge, and we need to apply the knowledge as a skill, and when you're looking at knowledge, we've got to have civil engineering knowledge, some understanding of the civil engineering, because we're cutting a hole in the pavement, for inset lights. We need to have a mechanical engineering understanding, because we've got bolts that we've got to tighten. And what happens if a bolt shears? What are you going to do about it? So we're going to have mechanical engineering understanding and electrical engineering, and the different types of electrical engineering, be it communication, be it power, you know, the electronics side, distribution side. There's a whole range of electrical engineering knowledge that we must have, but we need to apply that knowledge upon demand. So all these elements of knowledge, we have to apply it as a skill upon demand, and have the attitude, because we're going to have to be doing it when we're in the dark, you know, over the weekend, everybody's having fun on a bank holiday, all those kind of things, you know. You've got to have the attitude and want to do it. And I think a nice little statement here, that the greatest discovery of all time is that a person can change his or her future by merely changing their attitude. It's a very good statement, that. Okay, so what I'm going to say here is, you know, I've been talked long enough. What's next? Well, I think Robert is going to talk about that. What is next? Airside asset management in the future, and the PAPIs has already mentioned that. So just remember, you cannot manage what you cannot or you do not measure.
Thank you.
Wow. Robert, come in.
Thank you, Keith. If you'd like to come out of hiding, guys, my expert panel, I'd be appreciated. So thank you very much for that, Keith. Very informative. But I think you'll have a lot of questions. I can already see them coming in on the Q&A on the computer. So I'd like to just if you'd like to have a quick look at those, I'll ask them specifically. There are almost an infinite number of areas, and they're very much specific to, often very specific to your local conditions. So what we'll try and do is keep these answers as general as possible, given the large audience here, and we all want to take some benefit from these questions. So let me start from the top there. There are a number of techniques for, it's talking about installation of laying of underground AGL cables. If you want to get a longer, if you want to lay underground cables to ensure longer circuit life and easy fault tracing and troubleshooting, what is the best approach or best methodology? You've illustrated a number of methods, Keith. I know Derek, you'll have worked with them, and what's the recommended best practice here, boys?
I think I'd like to ask Derek. I know from my perspective, you know, different nations have different ideas. You know, the Netherlands, and they directly buried the cable, and others will put, it's mandatory to put them in ducts, and they're really the key issues. And you've got these great lengths as well, you know. So can you know, I don't know if you've ever been involved in cable pulling, but I'll tell you, it's hard work, eh? And so you have to decide what length you can actually pull. And I think, Derek, from your installation teams, you have great experience at this, eh? A more recent experience than me, eh?
Yeah, I mean, the best solution is a pit and duct system. But you've got to be careful. I mean, most of our installations, you've got limited amount of time to do them. Your point that you say 50% of your night shift or your day shift is going to be unproductive. You need to be very careful with how much you take on that night. You've got to plan for the unplanned. It could be an ambulance flight. Going back to the cabling, if you have the pit and duct system, try and separate your circuits if you can. But also, if you've got, say, runway centerline circuit, don't have your circuit going all the way around the runway edge. Keep your two cables, you feed and you return, in the same duct. Because for future fault finding, you've got both cables there. You can short out and you can check loops, either back to the substation or for the remaining end of the runway. So again, stop bar circuits and things like that. If you can keep your feed and return in the same duct, the same route, that is always better. Tricks of the trade, Derek, eh? Yes, yes.
Thank you. Thank you. Another question for Derek. Typically, tender documentation brings often incorrect and confusing project requirements. There are conflicts such as commercial documents, the technical documents, and the drawings have conflicts within them. How does an installation contractor typically address this?
It's always a difficult one. A lot of the specifications you usually find have been cut and pasted from previous projects, and then the drawings don't tie up with the actual specification. If the tender period allows, it's always good to put those tender queries in straight away, so that all other tenderers, our competitors included, get the same answers. Because the better that specification is bottomed out at the start of the job, the better it is for the client, because they'll be able to compare apples for apples. If everybody just runs off and does their own design and their own solutions, it's very difficult for the client to appreciate who's included for what and what benefits they're getting. A site visit is always great at tender period, and the best ones are where all the contractors are invited together, because I might think of a question that someone else hasn't thought of, but my competitor may think of a question that I've not seen in the documents yet. So those are the best ways of getting all the information out to all the contractors. And failing that, when you put your bid in, put a technical appreciation together, detail exactly what you've included, why you've included it. If you've gone down a certain specification away from the drawing, or if you've gone to the drawing and not the specification, highlight that in the tender. It saves arguments, all sorts of problems when the job actually comes to fruition, or if you're awarded a contract. I mean, the other thing is you can actually provide optional costs. So if there's something not quite right, but you're not sure if they want it or not, detail it out as an extra cost, but highlight everything technical that you thought of.
So a message out there to those that are actually tendering for work, please, I guess, attention to detail is absolutely critical for your own benefit, because if there's any confusion there, then it could potentially lead to you choosing a low-cost option that has inherent in it some flaw that you can't enforce because the contractual documentation has errors in it. So it's in all our interest that things are clear, accurate, and right first time. The next question I have here, I will answer myself, is from Mohammed, trying to put me on the spot. Can you please list down the name of the top leading manufacturer of high quality LED airfield lights? Well, it's very important in the work that we do, training and for photometric testing and working on airfields as a tester of equipment, that we remain impartial. Our aim and our objective is to help airfields get the best possible lighting they can. We choose we don't have any favorites in this world. We will give you honest answers. If something passes, we'll give you or fails, we'll give you the good news or the bad news. We always prefer to be giving you good news, but the main thing is you get the right answer. I mean, an accurate answer. And we'll work with you and the manufacturers, of course, to help rectify any issues if there are any. But as Keith said earlier, it's inevitable in any large project. There will be some problems, but we're always, I think, able to overcome them. The next question again is this one's for Keith. Keith, it says, I think we could have condition-based maintenance instead of preventative type. What do you have to say about that?
Well, I think if you're looking at the concept of which IKO recommend, which is the name in the Aerodrome Design Manual Part 4, we call this this whole element of differential maintenance. So I tend to call it targeted maintenance. So condition-based maintenance, you are actually potentially going to save money, because if you do preventive maintenance and you just say, oh, I'm going to do it every week, every month, or every day, whatever cycle you're going to do it, you may actually do maintenance that you do not need to do. But if you do condition-based maintenance, or as I call it, differential maintenance, you're actually maintaining what is needed to be. So I like the condition-based maintenance concept. I think it's more effective. and you're using the tools that are available today as well. And you can keep electronic records in real time if you've got a sensible and a good asset management control system associated with it. So yeah, condition-based maintenance, I say targeted maintenance, call it what you like, is preferable. You still need to have preventive, you know, that certain things, you know, you know, for example, you may well know that if you've got records and your cycle of rubber burning onto touchdown zone lights and runway centerline lights, etc., then you know very well perhaps you have to clean them once a week or once a fortnight or once a month, etc. So that is part of preventive maintenance, eh? Because it's pretty clear because your traffic density is the same, eh? So you've got a cycle. So that is part of preventive. And I mean, but when it comes to some of the other elements, then you can say, okay, let's measure, like doing a photometric test. That's a condition-based maintenance, isn't it? You measure the output. If the output is above, as we would say today, 70%, then we don't yet need to do maintenance. So I think that's the answer for that.
Okay, I think another one for Paul there. So what is the technique for measuring photometric values of elevated light fixtures?
Okay, using our particular test equipment, the mobile trailer system can test inset fittings, elevated runway edge fittings using an arm which swings out from the trailer over the lights involved to measure. And for testing areas of the elevated approach, for example, where the lights can be on our particular system up to 1 meter above ground level, we have a sensor which goes on the side of the trailer and you drive in front of the lights with the lights shining on the sensor. So our trailer-based system can measure any type of runway lighting from inset up to 1 meter in elevation. But those lights that are taller than that, then we tend to have a small issue. We have places where they have lights that go out into the ocean or over a big cavern, and those kind of areas, our trailer is not suitable for testing those lights.
Okay, thank you, Paul. Next one is possibly the answer to this one will be come to Keith's training course, but I'll ask it, Keith, and if you could you can give that answer or a briefer one if possible. What are the best practices for maintenance of thyristor-based CCRs and LED lights along with associated circuitry?
Well, let's start with the thyristor-based CCRs. You know, when you migrate from tungsten halogen to LEDs, then the power demand is reduced. And with a thyristor-based CCR, when you install and commission, as Derek will know, then you have to set the tappings associated with and what you're really doing with that is you're selecting a CCR which is a greater capability than the need of the circuit in terms of power demand. And what you're doing is when you're tapping down a thyristor-based CCR, you are matching the CCR as closely as possible to the size of the power demand of the circuit. And in doing that, you are then reducing the potential of harmonic distortion. You are improving the power factor of the, and with tungsten halogen, then you have already done that, you know, in the commissioning and or during maintenance. You've checked that, and the tappings that you're making there's what is known as an 8/8, 6/8, 4/8, 2/8 tappings, fixed tappings, and you're matching. When you change to an LED, as an example, then the power demand has gone down. So what you really need to do is to readjust the CCR tappings to match, or and if it's and that makes the CCR work pretty efficiently, because there is some criteria associated with thyristor-based CCRs. Then you've either got, depending on the size of CCR, then you need to achieve a 90% or a 95% efficiency in accordance with the standards. Now, if you're outside that efficiency level, then what's happening if you do not do this, then you are going to use more power on the incoming side. So you're going to save electricity, basically, if you tap a thyristor-based CCR correctly. And the CCR will still work if you do not do this, but it will work inefficiently. And it's as simple as that. And if it's going to be working inefficiently, then when you walk into a substation, a vault, whatever you want to call it, you can hear it. You can hear it hum, or you can feel the heat coming off, because the efficiency loss is noise or heat. You know, because energy cannot be created nor destroyed. It can only be transferred. So if you want equipment to work efficiently, you've got to set it up correctly. So there's what I would say between the LED and the thyristor-based CCR. When it comes to the field equipment, and that's a big subject. And
I think that's...
Can I just add to that, Keith?
Yeah.
As well, with the maintenance of the CCRs, it's very important that they still do regular checks on the out-brilliancy settings and check that the open circuit trips work. A lot of people put those CCRs in and think they can forget about them, but the maintenance, there is a requirement to maintain those CCRs. Check your earth leakage, check your open circuit, check your trip levels. You don't want that current going up to 6.9 amps and then ruining all your light fittings.
So, Mohammed, I would recommend you come and join us on one of Keith's courses, is the answer, as I said. Now, one for you, Derek. Would you allow joints on primary cables that aren't at a transformer?
Yes, it's not ideal, but in certain circumstances where you've got a long circuit, say going from your V-center substation or CCR vault, whatever you call it, if that's going out to an approach, or a threshold or a PAPI circuit that's a good way away from the substation, cables are normally supplied on 1 kilometre drums. So very often it is a requirement to have a joint between the CCR vault and the first light fitting. In that circumstance though, we would recommend that the actual joint is made in a pit. It's identified on the as-built drawing, because that every joint is a weak point. And also, when you're making that joint in that pit, leave plenty of slack cable and make sure that that joint doesn't accidentally get pulled in through the duct. If you've got a joint in the duct, you've got all sorts of problems in the future.
Thank you. Next question, one for you, Paul. Question from Oswaldo. Is photometric test mandatory for any airport size and operation type?
Well, I would say regardless of whether it's mandatory, you should do it, because as Keith says, the key to all of these things is being able to measure the status of your airfield assets. If you can't measure it, then how do you know whether or not you're maintaining it effectively or not? So I would say, yes, it should be mandatory, even if you think it's not.
Right. Well, certainly the actual standards specify photometric testing for Cat 2.3 lighting systems, but also the standards also specify the requirements for Cat 1, Cat 2, and Cat 3. And you, as Paul says, you would not know if those standards were being met without measuring. And it is a requirement to have maintenance practices and measurements to be able to support good maintenance practices and meeting your licensing requirements for operations in the category designated for your airport. And talking about categories, one for you, Keith, Mohammed would like to know how we differentiate amongst Cat 3 A, B and C categories. What are the differences between Cat 3A, Cat 3B, Cat 3C?
Yeah, it's basically runway visual range. as you know, for the category criteria for AGL, no, we're talking AGL here, and when we go for category 1, for example, then RVR, runway visual range, that is when the pilot is sat in the aircraft on the runway, how far can he or she see the visual aids down the runway? That is runway visual range. So when runway visual range is 550 meters or greater, then that is category 1 criteria. When the RVR drops below 550 down to 300 meters, then that is category 2. When it drops below 300 meters down to 175 meters, that is category 3A. 3A. When it drops below 175 meters down to 50 meters, it is category 3B, and below 50 meters is category 3C. Now for airfield ground lighting, category 3, then if you think about it, you've dropped below 300 meters in runway visual range, that is category 3. And if you think that you are coming into land at 150, 200 kilometers an hour, and the approach system is 900 meters in length before the threshold, you're already 2/3 of the way down your approach before you visibly see the threshold lights in category 3A.
And I'd also point out, Keith, that the calculation of runway visual range is very much dependent on the performance of your airfield lighting. So it is inherent in the calculation on your transmissometer or forward scatter machine. So maintaining your airfield lighting to the required standard is a key performance criteria in the calculation of RVR. If you don't,
well, there is a thing now called IVR credit, isn't there, in the industry, where that if you can demonstrate compliance, the efficiency of your AGL, then it will because, as you said, in the calculation for the RVR, we actually input an efficiency level of the AGL. If you can demonstrate efficiency of your AGL, then that is fed into the actual calculation of the RVR, which will determine when you go to LVP, low visibility conditions. If you go to low visibility conditions later, then you can get higher density of aircraft landing in your facility.
Yeah, this is of course a UK-based incentive innovated with the UK CAA to encourage good maintenance and rewarding airports for maintaining their runway lights to a good standard. But regardless of where you are in the world, maintaining your lights to the required standard is essential for accurate runway visual range calculation. And if your lights are not to the required standard, your RVR will be overstated, which is very dangerous, potentially very, very dangerous. So, and we have a paper on that, and I'm happy to share that with you. In fact, I'll put it on the webinar website after this call. Next question here we have from Mohammed. How can we avoid water accumulation in transformer, housing or pits as it affects several overall IR values and deteriorates the male-female connectors?
Who do you want to answer that?
Well, Derek's looking very keen.
With difficulty.
The answer is good airfield drainage. Like Keith said, the pit and duct system does become a drainage system. So you need to have a sort of outlet from your pit and duct system into another proper drainage system that takes the water and everything off site. Failing that, you should try and keep your joints and your transformers as high as possible in the pit by, even tie wrapping the joints on top of the transformers. Just keep them as high above the water table as possible.
Yeah, one of the elements that is which Derek will know is during installation, and whether it's installation or maintenance, is then the additional protection that we put on connectors over and above what the manufacturers have designed, with the use of additional self-amalgamate, self-bonding tape, etc. You know, some people say to use heat shrink, but the heat shrink in the field is a very, very difficult thing to effectively use because of the temperature changes and the environment that you're doing it in. So the 3M tape concept is and it's something which has gone on since eternity, which is really why in one of my previous webinars I looked at the alternative technologies, which is contactless and not having connectors in the field, you know. But so there's some potential advantages of going down that route. But of course, most of our infrastructure is traditional, and we have hundreds and hundreds, thousands of connectors in the field. For every transformer, there's two connections, male and female connections. You know, so if you've got 300 lines, you've got 300 transformers. You've got 600 connectors. And as Derek will know, you know, as an installation contractor, the time of access is normally when it's in the night, you know, unsociable time, you're tired, it can be wet, it can be hot, it can, you know, it's not an easy job, you know. So the effectiveness of installation, putting connectors on, directly affects maintenance.
Right. Thank you, Keith, for that. We're now 10 minutes over time, but I'll just see if we can just cover in essence some other topics so that you're aware of what's going to be answered in more detail on our Q&As in the website. Clearly, some of these questions are quite broad in their content, and there are a number relating to how we manage the underground assets, the cabling, and the pits. This is a constant topic of conversation at all airfield lighting meetings and conferences I attend. It is a challenge depending on your local conditions. I won't go through them individually but Keith will be pointing you in the correct direction in the Q&A answers we'll post on the website. I have a question here from Mohammed suggesting that we have an airfield maintenance organisation such as the aircraft's AMO for AGL specialists to pool their knowledge and experience, and also have special training and expert logbooks. Now that's very interesting because in the UK we have a competency working group, also known as the Airfield Lighting Association, and we're working towards the formation of such an organisation where we can recognise the competence of individuals by recording their knowledge and experience, formal training on something such as a website that could be independently verified and could recognise the knowledge and understanding and expertise and competence of those individuals. It is quite a complex area, and Keith in particular we're looking to work with an IEC working group to actually recognise personnel and their standards and competency.
Could I interact in there,
yes.
Robert?
Yep.
I think it's Mohammed who's asked the question. I think it's from the Iranian Aviation Authority. So I've been in contact with Mohammed on this very subject, and he's offered to also work with us on this very subject. And I know he's done a lot of work in Iran on this very, very subject.
Well, thank you, Mohammed, for that, and we will continue to work with you through Keith on that particular point. Khaled has asked. He said you talk about short circuit, so that light fixtures between short circuits in line will be gone. Is there any control/monitor system similar to CMS SCADA for MV networks to move the shortcut circuit open point automatically?
I think maybe I can just jump in, and I think something with Daddy. A lot of when on a traditional circuit, and we have earths, and we can have open circuits where things trip out. But when we got earths, there've been a lot of people have come up with various injection tools to try and inject a signal into the primary circuit to try and then get the signal back, like you can in other areas of electrical distribution systems. But unfortunately, I have to say, I have yet to come across any effective system. I think the system, what I call the old-fashioned method of halving the circuit, and progressively identifying where a potential fault is, rectify that fault, and then do it again, half, and then it does not take long to identify exactly where the fault is. I bet you've got to be structural in your thinking about that, eh? Derek, maybe you...
The only thing I'd add to that is that some of the individual lamp control and monitoring systems that you can get for the lighting, whether it's within the fixture or if it's a separate unit, does feed back what current it's receiving and sending to the light fitting. So if you've got 2 earth faults and you've got, like you say before, with your dim lights, you can actually identify or have a rough idea where those faults are on that circuit.
Yes. Yes.
Thank you. Paul, one for you here. Somebody, someone who's remaining anonymous wants to do you out of a job. He asks, if you have LED lights, does this mean you have to measure them less frequently?
Definitely not. You should measure your lights on a regular basis, because there's a lot of talk in the industry about the longevity of LEDs and the fact that they're maintenance free, but they still get covered in dirt and rubber, and this will affect the photometric performance. And at the end of the day, if that photometric performance falls below 50%, that light will technically be a failed lamp and should have some form of remedial maintenance. You wouldn't know that it needs the remedial maintenance unless you've measured it. So therefore, you need to measure it, identify the fact that there's a fault at that location, and go to that location, and you may just find, oh, it's got a big rubber mark over it, so I'll clean it, and there's your remedial works done. But without doing that continual measurement, you will not know that that's the kind of fault that you have at that location.
Can I interact here, Paul? And I think one of the issues that I find globally in traveling around, either doing training or doing inspections and audits, is that say, but the standards say at least once every 6 months. So that's what we do. I mean, let's face it, it's once every 6 months when we know from any in-field photometric results that some airports will need to do things every week. Or
at the end of the day, these regulations are there for safety purposes, and your airfield should be a fully functional, safe airfield, 365 days a year, 24 hours per day. So in order to do that, would you just measure it once a year, or would you measure it as often as you could? Bearing in mind that the more often you measure it, the better chance you've got of detecting some of these faults, because you have historical data for these locations. And then if all of a sudden you find that some of your lamps suddenly become dimmer, then that's an indication perhaps that you should start going looking for an earth fault.
Right. So, and it all comes back to the, for photometrics or electrical performance or any other aspect of maintenance, you can't manage what you don't measure. So at that point, we're now 20 past the hour. I'd like to thank the panel for answering all those questions. Apologies for putting you on the spot. That's the nature of this thing. These questions come blind, but I think you did really well. I'd like to thank Keith for a very interesting and informative presentation, as usual. We will be back next week with a presentation on airside asset management. and then the following week with a PAPI masterclass with a presentation by Tony Smith, and both of these presentations will be followed by Q&A panel sessions as today. So I'd like to thank you. If you could send any questions in, Tony has specifically requested send questions early. There are some questions on today's list I can see in front of me. So thank you for those that have already submitted the questions. If we haven't answered your questions today, I'm sorry, there are a lot of them. We will answer them in our Q&A and put them on the website. Please feel free to contact myself or any of my colleagues at any time, and we'd love to help you. We're here to make airfields better, and so it's a pleasure working with you. Thank you for your participation today. Thank you for the panel, and most of all, thank you, Keith. And I'll see you all this time next week. Goodbye.
Bye.
Bye.